Good morning, everyone. It's a real pleasure to be here, and today I am going to talk about reliability in the context of AI, and this is a theme which is present in many of the talks you are going to hear today, but I just wanted to emphasize a bit on this aspect. So what is reliability? This is a definition according to the NIST, the ability of a system or component to function under stated condition for a specified period of time. And the reliability encompasses many things, has many kind of properties, like accuracy and correctness, consistency, predictability, robustness in the presence of unexpected inputs, and safety. And now, you heard this quite a bit, and I just want to, again, to emphasize that reliability is actually a critical aspect of the AI success. It's like without building reliable AI systems, it's hard to imagine how AI will have the impact everyone here hopes is going to have. And there have been many papers, academic papers, thought leaders like Dario Amodei always speaks about the importance of building reliable AI systems, AI agentic systems. And also, obviously, you have a lot of blogs across industry talking about the same things, okay? So now, it's the reliability, it's actually, you have that it's a key property of any kind of engineering system, including software engineering, software systems. And why is that hard? Why is it challenging? Again, you can look, at software systems, and we know there, over the 40 years experience or more, 50, well, more than that, 60, 70, is that building a feature, it's actually demonstrating it, prototyping a feature, it's actually quite easy. However, to productize it, it's much, much more difficult. It takes anywhere between 10 and 50 times more effort to productize a feature than prototyping and demoing it, right? And the main goal, actually, of productizing a feature is to make that feature or to make that system reliable, okay? To work as intended. And productizing a feature includes many things, like obviously testing and debugging, right? This is what you do. To put the feature in production, you really need to do that. Compliance, governance, and when you deploy it, you need to have observability and so forth. In this talk, I am going to mostly focus on the first bullet, testing and debugging. And how do you do that in software systems? Well, software systems consist of many components. Think about function, object, actors, task, subsystems, and things like that. And each of these components ideally has a clear specification, an interface, okay, which describes what are the expected outputs given the inputs. Also may describe what are the allowed inputs and many other things. And this is important because this allows us to write tests, which verifies that, for this input, I get the expected outputs. And this is fundamentally what allows us to test and debug the systems, right? You write this test, you see that test pass, and if they don't pass, this is how you are going to identify the component which fails, right? And in the components, then you go, sub-component and so forth, down to the line of code which violates this, doesn't function according to specification. And you fix the problem by changing the offending code and then rerun it, and hopefully you are going to pass all the tests, right? This is what you do iteratively, okay? Now, the problem is that debugging AI agents, at least from this aspect, is much harder. If you think about, we are talking about agentic systems, one of the key components of agentic systems is large language models. And you rarely have clear specifications. And therefore, if you don't have clear specification, it's even hard to know when an error, if an error even occurs, right? And It's also they are a black box. So even if you know the error, how you are going to fix it, and by black box meaning here is that I'm contrasting with a program or it's kind of white box because you can go down and identify maybe down to the line which has a problem. But here it's like almost it's like debugging. If you use that analogy, you have a program and you only can look at the outputs, and based on the outputs, you have to figure out what happens. Okay. So now that I kind of provide the framework, I'm going to talk about two projects. And one is Chatbot Arena, which is testing and evaluating large language models. And MAST, a new project done with a few of my colleagues and students here. And you are going to hear a little bit more about it later in the day, which is a taxonomy for errors in multi-agentic systems. LM Arena was previously Chatbot Arena. It's a human evaluation for large language models. Why do we care about it? We have a lot of benchmarks out there, right? And every day you have new benchmarks. It's because most successful AI applications, at least today, have the human in the loop, right? If you think about chatbots, right? Customer service. If you think about code assistants, they do have a human in the loop, okay? And therefore, you want to know how and to evaluate how these systems, how these large language models perform with real people, with real-world prompts, workloads, and hopefully in real time. So, and when you are going to have humans interacting with these systems, the one central element is kind of the human preference, right? And the human preference is kind of not very well defined, but without trying to define it more, I would say that it has two components, what we call substance and style. The substance is what you say, accuracy, factuality, right? Is a result correct? Right? It has the right information. But the other one is style. How the output look like, right? And it's kind of, it sounds much more superficial, right? But I want to make the point here, but it's also extremely important. And we know that, right? Presentation, we are going to give presentation. You know, bad presentations versus good presentations. The content can be the same, right? But obviously, a good presentation, you appreciate it. And why you appreciate it? Because you are going to get much more from a good presentation, from a bad presentation of the same content. But look further, everyone is using computers, right? Arguably, a computer which just has this kind of alphanumeric character, screen, can provide you the same information, right, as a window-based computers, right? But why we do prefer the window-based computers? Because we can do our work better. So in fact, the style determines how also reliably humans interact with systems, right? And it's not only in computer systems, it's everywhere. Designing cars, appliances, everywhere, right? Because a good, we call this UI UX, right? It helps people to be much more effective in ingesting, retaining, and processing the information. And this leads to reliability of how they interact with the systems. Okay? Okay. So what is LLM Arena? Probably everyone now knows by now. It's like you go, and I encourage you to go to the site. You can ask questions, and then you can get, like in this case, what is AI reliability? And then you are going to get answers for two anonymized and randomized large language models. And then you can pick which one is better, if you want. And all these votes, we just use to compute a leaderboard, actually to compute this rating in the leaderboard using Bradley-Terry model. And this is a general rating, but you also have rating on categories, different categories like coding, multi-turn, and so forth, hard prompts. And also we don't have only for text, but also for multi-modals, multitask evaluations, like obviously web development, search, vision, and so forth. In fact, this week we launched this kind of video arena, which is text to video and picture to video. And I have only demo in the stock here. And here the question is about, this is like the web page for this event. And I just want to animate it and show the Golden Gate Bridge appearing in the background. And I think on the back, someone has to help me here because I don't have. So if you can click. Okay, so if you play the one on the left. Okay, so this is one result. And one on the right, please. Whatever. Okay, so now you can vote which one is better. And if you want to have more fun, yeah, exactly. So you can go on Discord and play with it. Okay? Now we are talking about the style, right? So the question, okay, you have form, style, and so forth, substance and style. And it's always a question we are always asked, does the styles matter? And how much? And we have some kind of, we did have some analysis on this. This is last year, and this is also this year a new blog. It's, I think, very recently in April this year. The sentiment, it's kind of, the style here, what means is mostly the format of the output. The sentiment, it's also kind of the vibe, how the language. Is the answer positive or positively framed, negatively framed, has emoji in it, things like that. And here are just kind of results in terms of, the correlation. This is basically, some linear regression we run on the data we have. And if you look here about the length of the text, the answer, then the markdown, right? The formatting, right? You have a list nicely formatted, you header, bold, what is important in the answer. The highest impact, if you look at all of them, it's a length. And one of the reasons the length, the longer answers are preferred because typically also they have more details, okay? If you factor out the length, then the next one will be the markdown list, which you kind of expect is more kind of structured. So it's more important than the header and maybe and so forth. And if you look now in the most recent study, again, where we have also, this very negative, neutral, positive is kind of the vibe on the answers and so forth. Again, the answer length remains the dominant factor in impacting the answer, the preference of the users. But the one point I want to make, because there are a lot of things, written in, over X and net and so forth, emoji, right? People say, oh, it's like, it's easy to fool, not they say to fool, but which is the wrong word to start with. You can get, better if you have more emojis. And actually, it's not. It's actually, it has the number of emojis, the emoji count has a negative correlation, okay? Maybe this is something about the audience of Chatbot Arena, but this is what it's what the result. So LM Arena had a big impact, has, certainly much more than we ever dreamed. Now it has 3 million monthly users, over 10 million monthly conversation, over 1 million monthly votes we just reached this past 30 days. And we've seen over 700 models from 20 providers, model providers, and yeah. Yeah, thank you. Okay. So this was about the LM Arena, and again, what I want you to take away is that actually the style is very, very important, right? And paying attention to the styles is something you should do when you build these systems, because it's equivalent of paying attention to the UI, UX on building traditional systems. The next talk I'm going the next part of the talk is about multi-agent system failures at taxonomy. So this is Agentic Summit. We are talking about agents, and there are many, many agents up there. So now questions in this the context of my talk is about how reliable they are. And at least when we tried, the past 2 months and so forth, which is the data we have, many of these agents fails more than 50% on hard benchmarks, right? So here it's, the success is blue for different agentic frameworks. The failures, it's orange, okay? So the obvious question next is that why do multi-agent systems fail, right? So the goal of this project is to systematically identify, classify, and analyze the reasons why these multi-agentic systems fail, right? And I'm going to go pretty quickly over the next slide because I want to get to the end, because I have to say also something at the end. So how do we do it? We manually inspect it. Students, you know, here I have Melissa, Mert. Inspect it over 150 traces to build the failure taxonomies. You know, based on their data and their learnings, they design an LLM judge pipeline to evaluate over 1,000 more traces, right? And it's a data set which is public. And we have 95% agreement between this pipeline and the human evaluation labeling. And again, we open source both the data set and the taxonomy. And we look at a bunch of frameworks, okay? And what we came out with this taxonomy, and basically you have whatever bins here, you have specification issues, inter-agent misalignment issues, and verification issues. And the one point to take again, I am not going to go through all of them, obviously, I don't have time. But if you look on the right-hand side of the percentages, each of this kind of category is significant, okay? So the first is specification issues. So specification issues, you know, it's like there are everything about not understanding or disobeying the specifications, disobeying not only what the task specification, but your role in many of these agentic systems. You say, you know, each different agents, they have different roles. They do repetition, right, without making progress. There is loss in translation or some conversation information loss and so forth. And here it's, like for instance, in this case, you have this kind of in chat dev, is basically you are going to build the system, you have a CEO, you have a CPO, and you know, the software engineer and the tester and so forth, and they try to cooperate to implement a task. And in this particular case, the CEO starts by telling to the CPU the kind of what that the CEO wants from the CPO, but the CPO kind of stops the conversation, right? It's again like, you know, and you'll see, you heard a lot about these things. I think Jared early on. This is not about a limitation of LLMs, but also about how these agentic systems are designed, right? So, and there are many, many examples here that if you have a better design, you can improve the accuracy and for the particular task, even keeping the same models, the same models, right? The next one, the next category is inter-agent misalignments. These are, you know, conversation also reset is like, fundamentally, a lot of these things are kind of lost in translation, right? It's like you say something, the other agent doesn't understand or makes things up or things like that. And here it's a very simple example. And I'm going to go quickly because I don't have time to go step by step, but I'm going to tell you what it's doing and what is the problem, okay? I'll give you that. So what you have here, basically you have a supervisor agent asking a phone agent to send a WhatsApp message, okay? And then, but the first thing you need to do, you need to log in the WhatsApp. So therefore you send the username and the mail and the, yeah, that will be a few more minutes, yeah. And what happens here, you send the information to the phone agent, and the Python executor asks eventually for here is like, is for the username and, you know, kind of the password, okay? And suffices to say that what happens here is that in order to provide to the executor, the Python executor, which eventually has to log in and to send him the message, the phone number you provide the email address, right? That's a kind of the confusion what happens on the phone agent perspective, from that perspective. But more than that, the error which is returned to the supervisor agent doesn't say anything about that. So you cannot fix, you don't know what is the problem, right? So something happens, it was lost in translation, kind of was confused, the phone agent, instead of giving the phone number, it gives kind of the email address. And this is not, was not even, this error was not sent back to the supervisor, that detail, so the supervisor agent cannot fix the error. Right? Okay, and the last one, so basically here you need real deeper social reasoning, meaning that what are the gaps in the understanding, in the specifications, and you need to fill them. The agent has to have that kind of knowledge. And the final one is task verification. Everyone knows about tasks. We are talking about the unit test and so forth. And here there are all these agentic framework, they do have some verification, some agent verifier. The problem is that they are quite weak. And even in simple things, like here it's about designing a chess. And it's like there are millions probably of chess programs on the web. And you've also asked to use a standard notation. So there are two things here. First of all, the agent fails to do it. You have things like pawns can move backwards instead of the notation like queen f7, they put x and y. That's okay. But the verifier, he says the program is good. Okay. So, so really here we can do much more. Okay. So I'm not going to go here. I'm just going to send you. Each line of this is for chat dev. Each column is for chat dev, sorry, and represent different categories of failures. And in each category you have subcategories. Again, the point to take away is pretty diverse set of failures. And this is for all this kind of agentic framework we look at. It's very diverse, but again, each of these kind of bars is significant, at least a few percent. Okay? And here we just launched, was today, about annotator web. So you can go there if you have your agentic framework and you are going to have your tasks, and you can upload here your traces, and we are going to use our pipeline to label the failures in your traces, and we are going to make it public and share with the community. So again, it's kind of. So in summary, I'll take only 2 more minutes, okay? So reliability is critical to the success of AI, okay? And there are 2 aspects of reliability we discuss in this. I discuss in this talk. One is about LLM arena, which is understanding human preferences, which is key to effective and reliable interaction with AI systems, and the MAST, which is trying to understand why multi-agent systems fail. Of course, you need to understand why they fail in order to fix them. And obviously, this is just a starting and many challenges to address. Probably 60, 70% or more from this room are working on these kind of challenges. So some parting thoughts here. Reliability, like we discussed, is important in every system we rely on. Okay? Period. Cars, appliances, everything. So it's a staple of the engineering disciplines, right? And reliability in AI arguably is more difficult than other systems. And one key here, which you have in this, how we get to the root of trying to build reliable systems in other disciplines, is to have good specifications for entire system, subcomponents, and things like that. Because these specifications allow us to verify the system works. If you don't know the specification, you don't know what the system has to do, what you are going to verify, right? So verification implies that you have some kind of specification. It also helps you to debug the system because especially, it's like because you have different components, you can end-to-end, it doesn't work, then each component, this component doesn't work, you go more in depth and so forth until you find the cause. Maybe you just replace the component, right? This is what we do with everything, right? It also allows you to decompose and reuse existing components. Right? Why? Because the components have a clear specification. Now you know how to plug them in. This is what we do in software engineering. This is kind of the exponential growth we have seen for the past, 40 years. And finally, today we have the human in the loop, but one of the reasons of the human in the loop, because the human is the ultimate decider about whether the output from that system is good or not, right? That's what you do in code assistance when you use cursor. You are the ultimate arbiter, right? Decider to say, oh, looks good, and I'm going to approve this kind of changes, right? If you want to go to automated decision making, which means no human in the loop, you need to trust this decision without the humans overseeing them, right? And you cannot trust them if you don't know exactly what that system is supposed to do, which means without having the specifications. And I think that basically, again, is like, I think we should learn, obviously, from other disciplines on how to build these reliable systems. And a few of us, which are many here, like Matej and others, we are very excited about this research direction. Thank you.